and Apex are not counting right now in your grade book, you still want to take it. Your Unit 4 CST score is really good feedback for you as to how well you are doing with all of the concepts in Unit 4, okay? If you get under an 80% on that, contact me. I'd like to reset it for you, go over any questions you have before you retake it again. You want to be getting A's and B's, okay, on your items in Apex, because that's feedback for you as to how well you understand the material. If you have extra time this week, if you are already caught up to pace and you have extra time, go through your grade book and resubmit any low summative assessment scores, okay? We have November MAP is going in next week. So I am looking for anything that is turned in math through the end of the weekend. So if you are a little bit behind, still work on the weekend, get it in, and it will count in my class for November MAP. Okay, what questions do you have about calendar items or any specific summative assessments that you see coming or anything in Apex? Okay, so before we move on, I want you guys to assess yourself how you are feeling about Unit 4, so linear equations. Depending on where you are in the unit, because I think we're all in a little bit different places in the unit. So just reflect on how you feel you are understanding based on your evidence that you have, your quiz scores, or checking your answers on your study guide and checkup worksheets. And please rate yourself. Oh, here comes Katie. Please rate yourself. You can just send me a private message in chat. When you go to send to, you can just send it to me, or you can make it public, whatever you're comfortable with. But please rate yourself on how you're doing with linear equations. So gonna rate yourself before we go over review. Good. Let's do 1 to 10. 10 is, and I'm gonna ask you guys again at the end. 10 is awesome. 1 is, what is a linear equation? Good. So please put that in chat. Hi, Katie.
Hi.
Groovy, good. Okay, so what we're looking for here as we go through is that at the end of this hour review, all of your scores are either higher than what they were or the same, okay? That's our goal. All right, giddy up. Okay, so expectation here is that you're writing things down if you don't have this information in your notes, or if you just want to write it down again in your notes, because that process is really important for your brain. So there were 2 forms of linear equations that we talked about in this unit, okay? Slope-intercept form, and what was the name of that other form of linear equations? If you know, you can go ahead and type it into that fill in the blank there with the color that you're using. Okay, I'll be orange today. Okay, the top version is slope-intercept form. Let's get these labeled here in our form. Somebody please label what the M is holding.
It's not letting me draw.
It's not letting you draw? With annotate?
It is.
Oh, okay. Hey, Finnegan. Perfect. Point slope form. Good.
Okay, now it's not.
Now it's not? The annotate's not working?
Yeah. Well, I can get it on to draw, and then it'll just go back to mouse and it won't let me draw.
Weird. What about, could you type? What happens when you type?
Okay, I think it's working.
Okay. Remember how mine kept disappearing last week? That was not fun. So it is finicky. Okay, in both these forms, I'd like you guys to identify what are your M's. M is holding the place for what? You can label that. What is B holding the place for? Good. Katie's drawing in slope for M. Good. And when do we use this form, slope-intercept form? We use slope-intercept form when we know the slope and one other point on the line, a very special point on the line.
Y.
Good, the y-intercept. So somebody go ahead and write in y-intercept there. That is when we use slope-intercept form, when we know the slope and the y-intercept. Ooh, nice. Malachi is labeling in our point slope form. Good. That x comma 1 is holding the place for the x coordinate of a coordinate pair that we know. Good. Okay, so you might be wondering as you're going through, well, which one's better? Well, they're better depending on what information you're given from the beginning, okay? Or the type of problem you're being asked to solve. So you're gonna wanna use your slope-intercept form whenever you know a slope and the y-intercept of your equation. You're going to want to use point slope form whenever you know the slope and 1 point on the line, or if you know 2 points on the line. Because remember, if you know 2 points on the line, we are able to calculate the slope. Good, so make sure this information is down in your notes. And now we are going to start practicing with it. I've found some problems from quizzes. Okay, any questions on this page before we go forward? Okay. So let me erase. Oh, perfect. Okay, let's find the equation of each line. So this leftmost one, we know 2 points on our line, which means we are able to find our slope. Oops. So let's calculate the slope for that leftmost problem. I see Katie is already doing the calculations in her handwriting there for slope. Okay. Good. So either you're finding the slope on the computer screen or you're finding it on your paper. You can type it into the chat if you want to check your work. Okay, so your slope is rise divided by run, or rise in this case. Good, you're doing 3 minus -5. Nice. All right, and then 2 minus 0 will be your denominator for that first one. Good. All right, so yell it at me, everybody. What is our slope of this leftmost equation? Good. 4. 4 over 1 or 4. Okay, so now for this leftmost equation, we have to decide what form of the equation can we use. If at all possible, we want to use slope-intercept form, the easy one, y equals mx plus b. Question is, do we have enough information to use it? So we know the slope. Do we know the b? Do we know the y-intercept? Do we know exactly where this line crosses the y-axis? Yay or nay? Yay, good, Malachi. So b equals then, in this case, -5. So go ahead and write your equation then. You have your slope, you have your y-intercept. Plug them in, substitute them in, and write your final equation for that leftmost problem. Y equals 4x minus 5. Is there another version, an equivalent version you'd like to check on that? You could write y equals 4x plus -5. That works. Anything you'd like to check on that one? Okay. Let's look at the second one here. Are we able to use slope-intercept form for that second one? Are we able to use this form, y equals mx plus b, over here? We know the slope. We can find the slope because we have 2 points on our line. But do we know the y-intercept with validity? Do we know for certain where it crosses the y-axis? We don't. We can approximate. It looks like it's about halfway in between right there. What is that, 6 and 8? Okay. So let's not use slope-intercept form. So we have to use the other form that we know. Look back in your notes. What's that other form? We have to use point-slope form on this problem. Good. Okay, and I see Katie has been working on this problem. Let's verify that we have, that we agree with the slope. Okay, so Katie got a slope of 2. Do we have, does anybody agree that the slope for that equation is 2? I'd like some confirmation before we get going. It is not fun writing on my computer. Okay. Did anyone confirm, is our slope 2 here? For our second problem. So Katie says slope is 2. Kaden, what did you get for your slope on that second problem? Joseph, what did you get for the slope of the second problem? And Malachi, what did you get for the slope? Okay, Katie agrees with 2.
I agree.
Good. Who's that, Kaden? Okay, thank you, sir. All right, so we have 9 minus 3 divided by 1 minus negative 2. Good. Joseph agrees with 2 also. All right, so 6 divided by 3. Good, also gives us 2. All right, hot dog. Okay, so point slope form, we are going to take 2 and we're going to substitute it in for M right here. In order to use this, we need an x1 and a y1 coordinate, or another way to think of that is another point on our line. Lucky for us, we have 2 points on our line. So we can choose which one we want to use. Katie, which coordinate pair did you use for your work?
I did 1, 9.
1, 9, you use this one. And tell us why you chose 1, 9. Is there
Because
benefit?
it doesn't have a negative in it.
Good. And it's always nice if we can avoid negatives if at all possible. So Katie, you substituted in the 1 for the x1.
X1
Good. And the
and
y.
the 9 for the Y1.
Beautiful. Okay, so this right here is her point slope form, which I completely agree with right here. Okay, then Katie, you went even further. Tell me what you are doing here.
I changed it into a slope intercept form.
You changed it into slope intercept form. And you did that by doing what?
I isolated the Y on one side.
Good. Remember how last week we talked about if you were gonna get a tattoo of slope intercept form, the big piece of that tattoo needs to be isolate Y. You get Y alone on one side. And so that's what Katie has done here through algebra. So it looks like you distributed 2 through the parentheses, okay? And then you added 9 to both sides. Katie, check this arithmetic right here. -2 plus 9, what do you get? We think we can estimate our y-intercept to be up at about 7, we think. So when I spot checked that -11, it looked a little off. So I knew that I was looking for an arithmetic error because your process looked great.
Yeah,
Good.
I didn't know which one it was going to be. I thought it was going to be 7, but I wasn't sure, so I just did 11. But
Okay.
would it be subtraction or addition? Subtraction, right?
Good. Let's look. Look at your graph. That value added at the end there represents your y-intercept, right? Where is your y-intercept here? Is this a positive value or is this a negative value? It's positive. And it's about at 7, we can tell graphically. And you can also simply look, -2 plus 9 makes +7.
I realized that like just before.
Good, good. So it should work both ways. Your algebra should match up with your graph. Okay, what questions do we have on either of these problems? Okay, so be ready for your unit assessments to be able to write the equation of the line regardless of what information you're given. Okay, 1 point, a y-intercept, and another point so you could find your slope. Over here we were just given 2 points, so we had to find the slope first. okay? And then use point slope form. All right, let's move to this next problem. Thanks for deleting your work, you guys. Okay. These were taken off of a quiz, 4.3 quiz. And these are some commonly missed problems. So let's talk about them real quick. Let's look at that top one. Which is not an equation of the line going through 3, -6, and 1, 2? Okay. So one way to do this would be to write the equation of the line. So first step, you're given 2 points. Your brain should go to, oh, first step is to find the, yell it at me.
Slope.
Whee! All right, so go ahead and find the slope. Good job identifying the important work or the important information there. All right, so slope, do this on your own paper or do it on the slide. Good. Once you have slope, please throw it into the chat. Okay, we have an 8 divided by -2. Go ahead and simplify that, Malachi. I agree with what you have. Keep simplifying all the way. Can it be rewritten as a whole number? Okay, Joseph agrees with you too, Malachi. Good, and I agree with both of you guys. Beautiful. Okay, well, shucks, we found the slope. Does that throw out any of our possible answer choices? All of our answer choices had 4 in the slope spot, didn't it? Wah, wah. Okay, so what should be our next thing that we could try?
We could make sure that all of the point slope forms have numbers that are actually in the 2 points.
Okay. So to verify the X and Y coordinates. All right, so let's do that. Let's see here. Looking for my pointer. There you are. Okay. This 3 is an X. Do we see it down here somewhere? Oh, I do right here, right next to the X coordinate. So that's good. Okay, beautiful. So then that must mean that this -6 then also needs to be in it. Good. And remember, it's the opposite, right? So we're subtracting a -6, which would make this positive. Good. So D works. Good. Okay. And this one works. B works also. Okay, you're doing the green check. It works. A -1 and a -2. Okay, good. I agree with that. Where in the heck did the values in C come from?
They got the points backwards because 1 is the X value, but it's in the place where the Y value should be.
Yes, 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 I agree. Yep, good. All right, so C is incorrect, right? The X and Y coordinates are switcherooed. Good. Okay, let's look at that next one. Which of these points lies on the line described by the equation below? Okay, so here's what we're gonna do. We have 4 of us in here and we have 4 possible answer choices. So you're each gonna get one to verify. Okay. So they're asking you to verify, does this work when we substitute in X and Y into the equation? Do you get a true sentence? So we have Malachi, Caden. Sorry, my phone is blowing up about something. Okay. Twitter. No, with phone calls. All right. Joseph, Malachi, Katie, and Caden. Okay. All right, so you want to substitute in your work. So Caden, you are on A. Do answer choice B. Malachi, you're choosing D. Okay. Katie, you do B.
Okay.
And Joseph, you are on C. So you want to substitute in your coordinate pairs into the equation and see if they are true. So Caden, are you there? Good. So Caden, you tell me what to write up here on the screen, okay? For your coordinate pair. Are you there? All right, Caden, are you there?
Going on. This is always very good.
Okay, so Caden, tell me what to write here for.
Y and X.
There we go. So what we're doing is we're checking right now to see if 9,3 works in our equation. So our equation is y minus 3 equals 5 times x minus 9. So we want to see if it's a coordinate pair, where if we were going to graph that line, would that line pass through the coordinate pair? Okay, so you're doing A. For A, what is your x value?
I can never remember this.
It's okay. It goes in order. X comma y.
Okay, so you put the 9 where the X was and the 3 where the Y is.
Beautiful. Okay, so go ahead and write this down on your paper. So we're going to have 3 minus 3 equals 5 times the quantity of 9 minus 9. Okay. Okay. So our job here is to get feedback. We're checking algebraically to see if this coordinate pair works in our equation. See if it is true, equals, if one side is equal to the other. All right, so what do you have on the left side? 3 minus 3?
Which would be 0.
Okay. And on the right side, we're left with 5 times what?
5 times 9, which would be 45 minus 45, which would equal 0.
Good, good.
So we're both
And with
equal to
those-
0.
Good. So 0 equals 0, which means what? What is the conclusion we can draw about this coordinate pair that we substituted in?
That it is true that it
It is-
can be used.
Good. It is true. It is a solution. It is a solution because it made our equation true. Good.
Why can't I see the B?
What's that?
Someone X'd out the B.
Oh, B did not work, it looks like. Okay, so A works. Okay. Katie says, and here's Katie's work over here for this, for B, coordinate pair of B. B does not work because she got negative 12 is equal to negative 60 when she substituted in the values. Okay, now look at all this work. Are we able to quickly look at these coordinate pairs and decide which ones work and which ones don't? No, we actually have to do some work here. Good. Joseph says his does not work. Good. Joseph, do you mind sharing what you got on both sides of your equation?
What I figured out is because since there's a minus in this equation, and since both of the numbers already have negatives, it would make it plus, and that's not what that equation is.
Okay. Good catch. Let's see. So algebraically, let's do a quick check here. I'm writing it up here up at the top. We substituted in -9 for x. So we're going to have a -9 minus 9. And then our y is -3. So we have a -3 minus 3. Okay. Ooh, -3 minus 3 is -6. -9 minus 9 is -18. -18 times 5 is a very large number or a very small number. So I agree with you, Joseph. Those two sides are not equal, so that coordinate pair will not work. Good. All right, and Malachi, yours also did not work, huh? Okay. Good, so only one of them works. You are gonna see this skill on your assessments, okay, this week. You're gonna be asked to identify which points are coordinate pairs on your line, okay? Questions on this before we move on? Okay. Okay, we're gonna call this a Katie special, since Katie already illustrated how to do this problem. So go ahead and write that down, the problem down. Y minus 1, or excuse me, y minus 6. I'm losing my cursor. There we go. Y minus 6 equals -4 times the quantity of x plus 1. All right. Which equation is the same? Notice all of our answer choices are in what form? These are all in
Slope.
beautiful slope-intercept form. Our original is given to us in point slope form. Okay. So in order for us to compare the two, we have to put them in the same form. Okay. So go ahead and on your paper or on the screen, you have your point slope form. Solve for what? Solve for y. Get y by itself and see which of these answer choices you get. Go ahead and do that on your paper. Okay, my work is going to be up here, so go ahead and check your work against mine. What we're hoping to see here is that your fluency is getting better, meaning your speed. And you just know what you need to be doing. I'm going to add 6 to both sides. So I'm left with y equals negative 4x plus 2 is my final answer in slope-intercept form.
That's what I got also.
Awesome. POTB. Pat on the back.
Forgot
Good.
to use, I forgot it was a -4.
That's okay. You found your mistake, right? Good. So
Yeah.
here's the hard thing about algebra, guys, and we've seen it a little bit today. You have to do your algebra correctly, but you also have to do your arithmetic correctly, right? So we're adding layers to your math. If I'm grading your assessment and you get your algebra correctly, you still get most of your points, okay? Even if your arithmetic is off a little bit, that's fine. I'm looking for algebra. However, your computer scored items, if it's wrong, it's wrong. The computer's going to mark it wrong. Okay.
I got
question on this.
-4 too.
You got -4 also?
Yeah.
For what? Oh, you got B?
Yes.
Okay, perfect, perfect, perfect. Okay. All right, let's move to this next one, see what else kind of trouble we can get into here. Oh, yay, parallel and perpendicular lines. How did these lessons go, guys?
They went really well for me.
It made sense, the lesson?
Yeah.
Okay. Okay, so let's fill this in. I pulled this notes straight off of your 4.1 study guide. Okay, if you are not using them and you are getting under 90% on your quizzes, it is time to start using your worksheets. Okay, it's silly not to because they give you notes and then you can use the notes as you are taking your quizzes. Okay, so let's fill in the blanks here. You guys can write all over this if you would like. Parallel, 2 lines are parallel if they lie on the same plane and never cross. What's a mathematical word that we could say for cross? Starts with an I. They never, good job. Never intersect. Awesome. So 2 lines are parallel if they never intersect. Okay, perpendicular. 2 lines are perpendicular if they lie on the same plane and cross at 90-degree angles. Another way to say 90-degree angle is a right angle. Good. Okay, and you are graphing, I'm assuming, at home. The best resource I have for you for graphing is a corner, when you're graphing perpendicular lines, is just a corner of a sheet of paper. Because look at, how big is that angle right there? 90 degrees. And so you can use your corner of sheet of paper to test whether or not 2 lines are parallel or perpendicular by holding it up to the intersection. Okay, so let's go ahead and look at number 2. So we found here parallel lines are going to have the same slope. So let's look at the second one here. Parallel lines are going to have the same slope. Because they have the same steepness. So this middle one, if the slope of the green line is -1/2, the slope of your red line is also -1/2. Okay, perpendicular lines are where things get a little bit more tricky. Perpendicular lines, who remembers what the relationship is?
They have negative reciprocal slope.
Good. So negative. So the sign changes. So look at these two examples. We have a perpendicular lines down here. Notice one of them is positive and the other line is negative. So this one has a positive slope and this one has a negative slope. There's no way that you can have two lines with positive slopes that are going to be perpendicular. One has to be positive, the other slope has to be negative. Okay, so they have negative slopes and then they have negative reciprocal slopes. So reciprocal is when you reverse the numerator and denominator of a fraction. And we have been talking the last couple of weeks. We always write our slope as a fraction or a whole number. We never, ever, ever write it as a decimal. And so that's really going to help you here when we're doing perpendicular lines. So let's look at this first perpendicular line down here. So if the green line has a slope of 4, so it's saying this green line has a slope of 4. Well, what's the negative reciprocal of 4? Because that is then the slope of the red line. Good, so it needs to be negative. Good, and then you reverse the numerator and the denominator. Good, so negative 1/2.
I can't see the equations down there.
I know, I can't either. So go ahead and just write one slope is 4 and the other is negative 1/4. Does that work, Katie? All right, let's look at perpendicular line, the second one over there. It says the slope of the green line is -3. So M is -3. So perpendicular line to it is going to be positive 1/3. Nice job. Like the collaboration. It is weird. All right, questions on this one? Good job writing on the no decimals. Love it. All right, let's see. What is in store right here on 4/4? Okay. All right, let's look at number 5 together. What is the slope of a line that is parallel to a line with a slope of 9? There you go, parallel, same slope, right? Okay, number 6. What is the slope of a line that's perpendicular to a line with a slope of -5? Good, positive 1/5. You got it. Okay, 7 and 8 are gonna require a little bit more work. So let's look at number 7. A line has an equation, y equals 1/3 x minus 5. Okay, find the equation of a parallel line passing through 3, 2. If the line is parallel, we know the slope because we know the slope of the original line. We know the slope is 1/3. And if the line is parallel, that means it has the same slope. So we know for our equation, m equals 1/3. And we also know a coordinate pair on our line, 3, 2. Look back to the very first notes you wrote today. What form of the equation can we use if we know a slope and 1 point on our line?
Point slope. And also it's not letting me draw again.
Oh man, maybe say something nice to it. See if that works. I agree, point slope form. So we're gonna have y minus y1 equals m times the quantity of x minus x1. We're gonna substitute in the information that we know. So our x is gonna be good, our x1 is gonna be 3, our y1 is gonna be 2, and we just substitute in that information. Y minus, what's our y1, 2? equals 1/3 times x minus, our x1 is 3. Good. So if you just did this on your own paper, please verify that yours jives with mine on your final equation for number 7. Okay, so where did I find these problems? These ones are from 4.4.2. Again, one of your worksheets in Apex. It's full of really good practice problems, guys, that you want to be doing before you take the quiz. Okay, so let's do number 8 then. The line has an equation, the same one as before, 1/3 x minus 5. Find the equation of a perpendicular line passing through 3, 2. Whoa, go Katie, quick on the draw. Okay, so let's find the negative reciprocal of this slope. Negative reciprocal, we're going to reverse the numerator and the denominator, and it's going to be opposite signs, so negative. And Katie recognized -3/1 is the same thing as -3, right there for our slope. Good, Katie. And then you substituted in x1 was your 3 value, your y1 value is your 2. And there's your final answer right there. You can draw. See, did it work? You just had to speak nice.
I think it did that after I typed.
Ah, got it. Got it, got it. Okay, what questions do we have on these ones? Parallel and perpendicular lines. Okay. Okay, let's review how to do our graphing with our linear equations here. Move that. Okay, so we want to match on this one, match each inequality to its graph. Then determine whether 0, 0 is a solution. Okay, so we have 4 inequalities and we have 4 graphs. Okay, here's our inequalities. Remind me, when is a boundary line dashed? We have 2 that are dashed.
When it's either greater than or less than, but not equal.
Good. So greater than, this one's going to be dashed because we have just the greater or the less than sign there. And then this one's also going to be dashed because the straight greater than sign. So that's telling us we want the coordinate pairs that are just less than the line, or the coordinate pairs that are just greater than the line, not on the line. Good. Okay, now how can we tell graphically whether 0, 0 is a solution? So let's look at this question here. Is 0, 0 a solution for this first graph, upper left-hand corner? So find where 0, 0 is on your graph, right there. If it is in the grayed out area, 0, 0 is a solution. So we would say this first one is yes, a solution. All right, what about the next one over? Is 0, 0 a solution? Notice 0, 0 is not in our shaded area, so it is not a solution for that second one. All right, third one down. Bottom left, is 0, 0 a solution? Nice, it's in the grayed area. Good, it is yes. Good, not a solution. Good, okay. What questions do we have on that one? Now, was this a new concept for you guys when you studied it? First time that you
Yes.
shaded? Okay.
I
Yeah.
just finished that section of it in iReady, and then I learned it, and I was like,
Crazy. That worked out great.
I should have just done the lesson before I started doing iReady.
Okay, what on these is the hardest part for those of you that have already done this lesson?
For me, it was remembering the dashed lines if they were equal to also, but I remember now.
Cool. And if you do your graphs by hand and you are doing it with a pencil, I always just draw in the solid line first. And then if it's dashed, I just go back and I use my eraser and dash them with an eraser. That's always the very last thing I do before I move on. I do a final check. Okay, was this supposed to be dashed or solid? So it's really important that you reflect on that question often as you're doing a new type of problem for you. What was the most challenging part for you? Because then you can do an extra check and really put emphasis on that for you before you move on. Okay, let's see here. Okay, I think this is it. Last, yep. All right, let's graph these two, and then we are done with our Unit 4 review. Isn't that crazy? Okay, let's look at both of these before we begin. One of these is in a really nice way to graph. One of these, if you squint really hard, is basically in slope-intercept form. Notice one of them has y by itself, that left one, okay? So when we are given an equation in slope-intercept form, it's pretty easy for us to graph. What is this 2 gonna be on that graph? It's our y-intercept. So we can instantly go and we can put in that coordinate pair on our graph. Good. So let's go up to, let's see if it disappears on me. Nope, it stayed. How nice. Good, up at 2. Then we use our slope to find more points on our line. I'm going to be happy when I get a new stylus in the mail. Find more points on the line using your slope. So our slope is 1/2 means I go up 1 and I go over 2 and I will find another point on the line. Good. Up 1 over 2, up 1 over 2. We can reverse both of those. We can go down 1 to the left 2, down 1 to the left 2. Beautiful. Okay, before we draw in our boundary line, it's going to be dashed or solid. So we want the values greater than or equal to. So it's going to be a solid line on this one. Because of that greater than or equal to. Good. I remember last week someone was able to draw beautiful straight lines. Thank you for that. And what do we need on both ends of our linear equation? To show that it's going forever and ever more in both directions. Good job, Malachi and Katie. We need arrows on both ends. Good. Okay, so now the last step is to see, well, what side are we going to shade? Are we going to shade the top or are we going to shade the bottom? Are the solutions to this inequality all the coordinate pairs on the top of the line, or are the solutions all the coordinate pairs on the bottom of the line? And to check this, we test 0, 0 in our equation to see if it's true, to see if it's a solution. So 0, 0 is right here. Notice it's on the right side of our line, or also under. Where are you? So we need to test it to see if it works in our equation. So you're going to substitute in that coordinate pair, just like we did earlier today with coordinate pairs, to see if it works in the equation. So I have 0 is greater than or equal to 1/2 times 0 plus 2. So all I did was I just substituted in 0, 0 for x and y there. And good, you guys think the top is going to be shaded in, huh? 1/2 times 0 is 0 plus 2. 0 is greater than 2, or 0 is greater than or equal to 2. The question is that true? Is 0 greater than or equal to 2?
No.
No, no, no. That means, therefore, 0, 0 is not a solution. Therefore, none of them on that same side are going to be solutions. But everything on the opposite side of the line will be solutions. So I really like how you guys shaded everything on the top. It's nice when you have a highlighter, huh? Beautiful. Beautiful. Okay, last one. Let's look at this right one. I know, looking at that equation, I know a slope and I know a point on the line. What's the slope? Good. Slope is 4. And what is the coordinate pair that we know on our line? Just extract the information straight out of point slope form. Good. That coordinate pair is 1, 4. Good. Okay. If we know a point on the line, plot it on your coordinate graph. We know 1, 4 is a point on our line. So over 1, up 4. Good. Okay. How do we find more points on our line?
We know the slope 4 divided by 1.
Good. Which means your rise is going to be 4, your run is 1. Rise is 4, run is 1. Good. Up 1 over 4, or you can go down 1 to the left 4. Beautiful. So look how steep that one is, right? Nice. Okay. Is our line going to be dashed or solid? Dashed. Good. Dashed or solid, you're going to look right here at your inequality sign. Because it's just strictly less than, it's going to be dashed. Beautiful. Okay, arrows on both ends. Good. Now, the last thing we have to do is decide, are we going to shade the right side or the left side? And we typically choose the coordinate pair 0, 0 to test. Except what do you notice about 0, 0 in this case? 0, 0.
It goes 3, 0, 0.
Yes, our boundary
That's the
line.
y-intercept.
Good. Our y-intercept is 0, 0 at our boundary line. So we're not going to substitute in 0, 0 to check. So pick another easy coordinate pair. The nicest one I know of besides 0, 0 is 1, 1. Both positive and the same number. Oops. So substitute in 1, 1 into your equation and let's see what happens. So we have 1 minus 4 is less than, so we're substituting it into this equation. 1 minus 4 is less than 4 times 1 minus 1. And we're trying to figure out, is this true? Does this coordinate pair make our inequality true? If it does, that means it is a solution. So -3 is less than 4 times 0. So -3 is less than 0. Is -3 less than 0?
Yes, it is.
It is. So that means that 1, 1 is a coordinate pair on our graph. It's a solution. That means that all the other points on that same side are also solutions. So that means we're going to shade the right side of our graph. Good. And there it is. Good. Okay, we went a little bit over the hour. I'm done with problems that I brought for us to review, but if anybody has questions, big or small, you want to go over problems you've come across that you need help with, or you have questions on a quiz or something, summative assessment, stick around and I am yours for help, okay? You guys have a good week, okay? Good rest of the week.
Okay.
Goodbye.
Bye, guys.
Bye. Thank you.
Bye. You're welcome. Good job today.
Thank you. I'll see you next time.
Okay.
Bye.
Bye.